module number 3, levels of measurements, and this section number 1 is about the variables. As you know, the variable is a quantity that may vary from object to object. For example, this is a pointer, so it has got a variable, that is basically its length is the variable. So whatever the variable is, right? So variable could be weight, or it could be marks or length or temperature, time, etc. These are all different kinds of variables. So sample or the data set is collection of different kinds of variable and its quantities in it. So that is called the data set. So there are two kinds of variables. One is called univariate, as well as the other one is called multivariate. So univariate means only one variable taken at a time, while multivariate means more than one variable taken at a time. So there are two different kinds of variables. In one manner to classify variable is that is it actually an independent variable or is it a dependent variable. So variables that can actually vary one to another, of course. The independent variable means that variable that actually doesn't cause any change on its variability. So variables whose variation doesn't depend on other variable is known as independent variable, while variables that actually the variability depends on other variable is known as dependent variable. So an example of the independent variable is your age. For example, my age is not dependent upon any of the other circumstances, right? Or the time. These are all independent variables, while dependent variables are something that depends upon. For example, marks that you get in an exam is a dependent variable that depends upon various independent variables. For example, the time that you spent on the study is an independent variable. So that actually causes change in the dependent variable, that is the marks that you obtain in a class. For example, algal growth rate is dependent upon both time as well as temperature, as well as the photon flux density, that is light intensity. So light intensity and temperature are both independent variable that cause change in the dependent variable. And of course, it can be just one independent variable that can cause change in two or more dependent variables as well. For example, exercise is an independent variable that can cause change in insulin level as well as body mass index, BMI. So factors is an independent treatment variable whose settings or values are controlled and varied by the experimenter. So intensity setting of the factor is known as level. So there could be multiple levels of the single factor. So the factor is nothing but an independent, or it's a treatment variable. It's not a dependent variable at all. So levels may be quantitative or qualitative too. So it could be either present or absent. For example, present or disease or absent of a disease. So it could be the levels as well. So it could be like intensity setting like 0, 1, 2, 3 could be the levels as well. Effect of temperature on resistor. So you can measure the resistance before and after placing the resistor in 3 different ovens set at 3 different temperatures. So in this case, the temperature is a factor, while 3 different temperatures sitting are known as the levels of it. So effect of temperature and heating time on resistor. So in this case, we have got 2 factors, that is temperature as well as time, heating time. So and it can also have different kinds of levels of the measurements. So one way to know is that actually independent variable or dependent variable is to plug into this very simple statement. The statement is that independent variable causes change in dependent variable, while a dependent variable cannot cause change in the independent variable. One example would be time spent studying causes change in the test score, of course, but change in in the test score, it doesn't actually make any sense. The reverse doesn't make any sense on that. So you can simply plug on to this particular statement to see is it actually dependent or independent variable. So how do you test two variables are dependent or not? It's actually very tricky. Is it really one causes change in the other, or the other causes change in the first one? So you can do that using correlation, but again, which one causes change in the other one is impossible to know it, unless you actually do a regression as well. So correlation does not mean causation. That is a very important principle in the statistics. Now variables can be discrete or continuous. So discrete variable versus continuous variable, what is that? Discrete is categorical variable that can only take on a finite number of values. For example, number of children given birth to, or number of atoms in a bar of soap, or number of cycles passing through a traffic signal, etc. So you can count these variables For example, number of children can never be 2.5, it has to be an integer. So it follows a discrete probability distribution. So there are two kinds of probability distribution, we are going to discuss it later. So one is continuous distribution, that is Gaussian or continuous distribution, while the second one is called discrete distribution or Poisson distribution. So discrete variable or categorical variable follow Poisson distribution or discrete frequency distribution. So there are so many examples as you can see in this screen. For example, number of particles emitted by radioactive source is a discrete variable. Apgar score, for example, parity or the gender or number of death or number of mutations, whatever the things that you can measure or you can count are known as the discrete variable. While variable that are continuous can take on infinite number of the values. So it depends upon the level of the measurement. That is what we are going to discuss about. For example, this pointer is actually, what is the length of this pointer? I can measure the length using a small scale and I can say that it is around 10. Then I can also use a more precise one, for example, vernier calipers I can use, and I can say it is 10.12, or I can increase the accuracy, I can say like 10.10142 if I use a digital vernier calipers. So that is what the variable that can infinitely take on any number of values is known as continuous variable that changes continuously. For example, height, weight, all these are actually continuous variable, and continuous variables follow Gaussian distribution while discrete variables follow Poisson distribution. So this continuous variable, when you measure the continuous variable, it depends upon the precision of the measurement. So the precision means that it is actually the number of decimal digits of the measurement is known as the precision, while accuracy is absolute difference between the measurement and the real value is known as the accuracy. So accuracy and precisions are different. So it can be extremely precise, for example, a vernier calipers which is not really formatted properly or it is not really calibrated properly, it can still say that the length of this particular pointer is 100.172. So 100 centimeter is totally inaccurate, though it is the value is highly precise. Precise is nothing but, precision is nothing but number of digits, significant digits in the measurement. So when a group of numbers is reported, nominal limits is the group that has lowest and the highest reported the value. So the nominal as well as real, the two kinds of limits are there. What is this nominal limit as well as real limit? Nominal limit is the largest value and the lowest value, that is basically minimum and maximum, that is called the nominal limit. But the real limit means that real limit is actually the number from which it is actually rounded up from is the lower real limit. For example, there are 3 persons weigh 43 kg, 55 kg and 67 kg. So 43 kg is the minimum, right? But in fact 43 kg would have been 42.5, isn't it? 42.5, the rounded up will be 43 kg. So the 42.5 is the real lower limit, while nominal lower limit is 43, but real lower limit is 42.5. Now 67 could be 67.4, right? So non-inclusive is 67.5, just for the sake of limits. So it has to be 67.5 is being taken, that is non-inclusive, it is not actually part of that. So 67.5 is the real upper limit, while 42.5 is the real lower limit. So because of these two kinds of limits, so we have two types of range. One is called exclusive range, the other one is called inclusive range. So exclusive range depends upon nominal limits, while inclusive range depends upon the real limits. So exclusive range is nothing but maximum minus minimum, that is nothing but a range, while inclusive range is upper real limit minus lower real limit. So in the previous example, it is 43, 55 and 67, that is the lower limit I told you, the real lower limit is 42.5, while the real upper limit is not really 67. So it is not really 67, but it is 67.5. So 67.5 subtracted with 42.5 is 25. So 25 is the the inclusive range, while exclusive range is just 24. So, 1 is extra to it because of the precision of the measurement. So, roadside weighing station of the trucks that rounds to the nearest 100 kg. This is another example, round to the nearest 100 kg. So, the weights are 22,700, then 14,300, then 22,400 and 19,100. So, marks nearest rounded to the nearest percentage is another example. So, of course, 86 percentage marks means it is again, it could have been 85.5, it is rounded up from 85.5 to 86. So, votes obtained in the election, for example, the votes are actually not a continuous. So, these limits are only for the continuous variables, while votes are discrete. So, there is the limits do not apply to the votes because that is actually a discrete. So, it is very important that you have to know what is actually discrete or continuous. For example, number of channels in your TV is not a continuous, it is discrete. You can count on it. So, discrete variables are the variables that you can really count, while continuous there is no way to count, you have to measure, and the measurement depends upon the accuracy and precision. The precision is nothing but number of decimal digits in a measurement is that one. So, variables can also be qualitative variable, quantitative variable is a variable that you can assign number to it, while qualitative variables are the variable that cannot be expressed in numbers. For example, level of happiness, there is no way you can put a number to it, or beauty or ethics or love, etc. These are all known as qualitative variables. So, some qualitative variables can be grouped into different labels or categories, for example, gender, nationality. So, such variables are known as categorical variables or attribute variables. So, attribute or categorical variables are the one which you can categorize. For example, igneous rocks, different kinds of rocks you can actually categorically categorize into. So, discrete probability distributions follow Poisson distribution that you can see on the left side of this panel, while continuous variables follow Gaussian distribution, that is actually a normal distribution, a bell shaped distribution that you can see on the right of this thing. More on it later. So, variables can be discrete or continuous. That is very, very important to know, is it actually a discrete variable or a continuous variable. And then as explained to you, variable can be independent variable or dependent variable. So, one good example for independent variable is your age, while dependent variable is what is actually being changed, because influenced by the independent variable. And then variables can be qualitative variables or quantitative variables. So, two kinds of variables are qualitative as well as quantitative. So, in summary, variable is a quantity that may vary from object to object. Collection of values of a variable is known as a sample or a data set. Variables whose variation does not depend on other variable is known as independent variables or the treatment variables, also known as factors. Variables whose values are dependent upon other variables are known as dependent variables or outcome variables. In scientific experiments, only dependent variables are measured. Levels of the independent variables are set part of the scientific experimental design. To find association between two variables, correlation test can be employed. However, correlation can never reveal which is dependent and which is independent variable. Variables that cannot be expressed in numbers are known as qualitative variable, while those that can be expressed in numbers are known as quantitative variable. A discrete or categorical variable is a variable that can only take on finite number of values, while continuous variables can take on effectively infinite number of values. And it needs to be rounded to the nearest integer. So, the limits comes in picture of the independent in terms of the continuous variables. Precision is total number of decimal places in a measurement, while accuracy is the absolute difference between the measurement and the real value. While nominal limits are synonymous to the minimum and maximum, the real limits are either lowest value that the lower limit, lower real limit could have been rounded up from, or highest value in which upper real limit could have been rounded down from. Then there are two kinds of ranges, inclusive range as well as exclusive range. So inclusive range is depends upon the real limits, while nominal limits are used to calculate exclusive range. I hope you enjoyed this video. Thanks for watching.